Good morning, everyone. We are talking about 10.5 today, which is independent and dependent events. You should be able, by the end of the video, determine if compound events are independent or dependent. Think about you as a 7th grade student. You rely on somebody else to take care of you, to provide food, water, shelter. Your mom and dad, your grandma and grandpa, your aunt and uncles, whoever, they are adults, which makes you dependent on them. They raise you to become independent, where you can live on your own and take care of yourself. It's kind of like what we're talking about today. So first thing we're going to talk about is events that are independent. Okay, independent events. They are where the outcome of one event has no effect on the outcome of the other events. This could be 1, 2, 3, 4, 5 events in a row. So for example, rolling a number cube and flipping a coin are independent. Why is that? Because they don't have any effect on each other. Whatever I roll on the cube doesn't matter and won't affect what I'm going to flip on my coin. They don't have anything together. These will also say sometimes with replacement, meaning if I pull a card out of a deck of cards and I say pick 2 cards but replace the first one before you pick the second one, that is with replacement. Okay, so it says find the probability of rolling a 4 and flipping a heads. Because these are independent events, what we do is we take the probability of event A and multiply it by the probability of event B. If it was 3 events, you would take it times the probability of C. So we want to know the probability of rolling a 4 and then the probability of flipping a heads. Okay? Well, the probability of rolling a 4 on a cube is 1 out of 6. Times the probability of flipping a heads, there's 1 head out of 2 sides of the coin. So the probability of rolling a 4 and flipping a heads, 1 times 1 is 1, 6 times 2 is 12. So the probability would be 1/12. Okay? I don't like to do it the other way. It's easier doing it this way. So then we talk about probability of dependent events. Dependent events is when the outcome of one event does have an effect on the outcome of the other one. If you're drawing 2 marbles in a row from a bag without replacing the first, those are going to be the key words, without replacement. Okay, meaning that you are not going to have the same amount of marbles to pick from. For example, if I have a deck of cards and I say, okay, we're going to pick 2 queens, I want to know what the probability of picking 2 queens out of the deck are without replacing the first one. Well, in a deck of cards, the first draw you have 52 to choose from. The second draw you only have 51 to choose from. When you have a different number to choose from, those are dependent events. Okay, so it says a bag contains 3 blue and 5 red marbles. Find the probability of drawing 2 blue marbles in a row without replacing. Those are dependent events. The total number of marbles in the bag is 8. And then there are 3 blue marbles. So the probability that you draw a blue marble on the first one is 3 out of 8. Now, we've already could have possibly pulled one of those blue ones out. We now only have 7 to choose from. And it says if you drew a blue marble on the first one, let's say one of those came out on the first draw, you only have 2 left. Okay, so the probability of the second one is 2 blues that could be left out of only 7 in there. So what you do is you take the probability of the first one, which is 3/8, times the probability of the second one without replacing the first one, 2/7. And I'm going to cancel. That's a 1, that's a 4. Go straight across. 3 times 1 is 3 over 28. Okay? Okay, it says decide whether each is an independent or dependent. It says a student spins a spinner and rolls a number cube. 2 events. Does the spinner affect what's going to come out on the cube? No, it sure doesn't. So these are independent because they have no effect on the other one. Okay? Then it says a student picks a raffle ticket from a box and then picks a second raffle without replacing the first one. Okay? Notice you pick a ticket out of the box. Let's say there's 10 tickets in there. They don't replace the first one. So how many do you have to choose from for the second one? 9. So these are dependent. One does affect the other one. All right. So it says find the probability of the independent events. You are picking a black checker from a bag of 6 black and 4 red checkers. We are replacing it. That's key to it being independent. And picking another black. Okay? So we have the probability of the first one being black times the probability of the second one being black. Okay? Well, there are 6 black ones in there out of 10 total. We put it back in, you have the same chance, 6 out of 10 for the second one being black. Okay, so I'm going to cancel 2 goes in there. That's 3, that's 5, so is this one. Go straight across and we get 9 over 25 chances. That would be B. 4, rolling a 6 on a number cube and then rolling an odd number. So we have the probability of a 6 on the first one times the probability of an odd. So probability of a 6 is 1/6 times the probability of an odd number. There are 3 out of 6 that are odds. I'm going to cancel. 1 times 1 is 1 over 2 times 6 is 12. So that one's probability is 1/12. Okay, flipping a tail on a coin and then spinning a 5. Well, that would be independent. Probability of a tail, because they don't have anything to do with it. And then probability of spinning a 5 on a spinner with 1 through 5 spaces. So probability of tail is 1/2 times. There's only 1 5 on that spinner out of 5 numbers. So you get 1/10. D. Drawing a 1, 2, or a 3 from 9 cards numbered 1 through 9, replacing it, so again it's independent, and drawing a 7, 8, or 9. Okay, so we have probability of a 1, 2, or 3 times the probability of a 7, 8, or 9. So there are 3 out of 9 here, times there's 3 here out of 9, which is really a third times a third, right? Which would be 1/9. Okay, solve. There are 4 black marbles and 2 white marbles in a bag. What is the probability of choosing a black marble, not replacing it, so these are dependent, and then choosing a white marble? Okay, so it's probability of a black, not replacing it, times the probability of a white. Don't replace. Okay, what's the probability you pull a black one? Be 4 out of 6 times we have 1 less now to choose from, which would be 5, and then we want a white. There are 2 white ones. So I'm going to cancel. That's a 1, that's a 3, and I get 4 out of 15. Okay, this is workbook page 228. We're only going to do a few of these. So 1, 2, 3, and 4 are saying you're rolling a number cube twice. Well, one number cube doesn't affect the other, so they're independent events. Okay? So number 3, probability of rolling an odd. Well, there's 3 odds out of 6, so it's 3, 6 times the probability of rolling a 2 or a 4. That's 2 out of 6, which I'm going to cancel. That's a 1, that's a 2. That's a 1, and that's a 1. And you get 1/6. Okay, 4, probability of rolling a number less than 6. There are 5 of those out of 6, times probability of rolling a 3 or a 1. That's 2 out of 6. That's a 1. That's a 3. And you get 5 out of 18. If you look at 5 through 9, it says you're randomly choosing a letter from a hat with A through J. Without replacing the first letter, you choose the second one. So these are dependent. Okay, because we have one less to choose from. Probability of choosing an H, there's only one out of, well, A through J is 10, times a D, there's only one D out of there, and we already chose one and we didn't replace it, so there's only 9 left. So that would be 1 out of 90. Choosing a consonant, and then an E or an I. Okay, a consonant, there's 7 of those out of 10, times we only have 9 left to choose from. An E or an I, that's 2. So I'm going to cancel, and you get 7 out of 45. Look at number 9. You have 3 bracelets, 4 watches, 5 stretch bracelets. You randomly choose 2. What's the probability you would choose 2 watches? It doesn't say we were replacing it, so they are dependent. So the probability would be 4 out of 12. Okay, there's 4 watches. What if that first one was a watch? There are only 3 out of 11 now. Okay, so we're going to cancel. We get 4 out of 44, which is 1/11. All right, now this time it says you flip a coin and roll a number cube twice. These are independent because one does not have any impact on the other one. So we want to do a heads, a 5, and a 2. So probability of a heads is 1/2. Rolling a 5 is 1/6. And rolling a 2 is 1/6. 1 times 1 times 1 is 1 over 72. 11 is flipping a tail, an odd, and a 4. So it would be 1/2 times, there's 3 odds out of 6, times a 4, there's 1 out of 6. I'm going to cancel, it's 2. 1 times 1 times 1 is 1 over 24.